NASA is officially shifting its lunar strategy. In a massive announcement, NASA is canceling plans to deploy the Lunar Gateway station in orbit and will instead reorient resources to build a 20 billion base directly on the moon's surface. In this episode of Astral Adventure, we break down what this $20 billion 7-year plan means for the Artemis Program and the future of human habitation on the moon. Key topics covered: why NASA is abandoning the Lunar Orbit Gateway Station, the new $20 billion 7-year surface base project, how existing pre-built components are being repurposed, the race factor and competition with China's 2030 lunar plans. America will never again give up the moon, says new NASA Chief Jared Isaacman, aiming for a permanent human footprint rather than just flags and footprints. The pivot to the pavement, NASA's $20 billion gamble. For years, the blueprint was set. NASA's Gateway was meant to be the crown jewel of the Artemis program, a shimmering high-tech outpost orbiting the moon, serving as a pit stop for astronauts before they descended to the surface. It was the gateway to the stars. But in a stunning midnight correction, the orbit is being abandoned. Under the bold direction of NASA's new chief, Jared Isaacman, the agency has hit the cancel button on the orbital station. The reason? A realization that to truly own the moon, you have to stand on it. Instead of floating 250,000 miles away in a lunar tug-of-war, NASA is redirecting every cent of that $20 billion budget directly into the lunar dust. The new mission, the $20 billion foundation. NASA isn't just sending a lander, they are building a city. The plan is a grueling 7-year sprint to establish a permanent habitable base on the moon's surface by 2033. This isn't about flags and footprints anymore. This is about infrastructure. The agency is reportedly repurposing the massive modules originally intended for the gateway, life support systems, docking ports, and power grids, and redesigning them to sit on the lunar South Pole. It's a logistical nightmare turned engineering miracle. Why the sudden U-turn? The shadow of the new space race looms large, with China aggressively targeting 2030 for their own lunar settlement. NASA realized that an orbital station was a luxury they could no longer afford if they wanted to secure the best real estate on the surface. By moving the station to the ground, NASA creates a permanent port for mining water ice and testing the life support tech needed for Mars. As Isaacman put it, America will never again give up the moon. For the crew of Astral Adventure, this marks the end of the Gateway era and the beginning of the lunar frontier. The $20 billion question remains: can NASA build a skyscraper on another world before the clock runs out? In a major strategic shift, NASA Administrator Jared Isaacman announced on March 24, 2026, that the agency is pausing the Lunar Gateway space station in its current form to prioritize a $20 billion permanent lunar surface base. This ignition initiative aims to establish a continuous human foothold at the lunar South Pole over the next 7 years. The strategy: pivot to the surface. NASA is repurposing components originally built for the orbiting Gateway station to fast-track ground infrastructure. This move addresses the great power competition, specifically the need to outpace China's plans to land astronauts by 2030 and build their own international lunar research station by 2035. 3-phase implementation plan. NASA's roadmap for the $20 billion investment follows a modular 3-step approach. Phase 1, build, test, learn, rapid delivery of rovers and scientific instruments via commercial partners to test nuclear power, navigation, and communications on the surface. Phase 2, early infrastructure. Construction of semi-habitable areas and mobility systems to support recurring astronaut operations. Phase 3, permanent presence. deployment of heavy permanent habitats with life support systems to sustain long-duration stays, technical and geopolitical stakes. The Mars Link, a nuclear-powered spacecraft, Space Reactor 1 Freedom, is planned to launch by 2028 as a precursor for deep space travel. Partner impact: the sudden pivot has left international partners like Canada and Japan scrambling to adapt hardware like the Canadarm3 that was designed for an orbital station. Current progress: as of April 10, 2026, the Artemis 2 crew has just completed a record-breaking lunar flyby, setting the stage for a crewed surface landing now targeted for 2028. Here is a deep dive into the technical repurposing of the Gateway hardware and the strategic geography of the lunar South Pole. 1. The technical pivot from orbit to dust. NASA isn't throwing away the billions already spent on the Gateway. They are literally dragging it down to the surface, the PPE, power and propulsion element. Originally a high-efficiency solar electric tug for the orbit station, it's being redesigned as the primary power grid for the base. It will serve as a massive 60-kilowatt solar farm to keep the lights on during the long lunar nights. Halo, habitation and logistics outpost. The crew's living quarters won't be floating. They're being reinforced with landing legs and additional radiation shielding regolith ready to become the foundation module of the surface base. Canadarm3, the robotic arm, originally for external station repairs, will now be used for lunar construction, moving heavy cargo from landers to the base and clearing landing pads of moon dust, regolith. 2. Why the South Pole? The strategic high ground. The decision to build at the South Pole isn't just for the view, it's for survival and sovereignty. The peaks of eternal light: there are specific ridges at the South Pole that receive near constant sunlight. This is the Saudi Arabia of solar power. Whoever controls these ridges controls the energy supply for the entire moon. Permanently shadowed regions, PSRs. Just a few kilometers from those sun-drenched peaks are craters that haven't seen sun in billions of years. They are filled with water ice. This ice is gold. It provides drinking water, oxygen, and most importantly, hydrogen for rocket fuel. The Shackleton Crater Advantage. NASA is eyeing the rim of Shackleton Crater. It offers the perfect mix of high ground communication, direct line of sight to Earth, and proximity to deep ice mining. 3. The China factor in the soil, the race for the rim. China's Chang'e 7 and 8 missions are targeting these exact same spots. By moving the $20 billion station to the surface now, NASA is effectively staking a claim through physical presence. International law: while no one can own the moon, the Artemis Accords establish safety zones. If NASA builds a $20 billion base first, they legally create a buffer zone that others must respect, effectively securing the best water ice resources for the U.S. and its partners. This segment of your Astral Adventure focuses on the lunar gold rush, the high-stakes engineering of water ice mining, and the controversial legal safety zones that come with a $20 billion price tag. The lunar gold rush, mining the dark side. The $20 billion station isn't just a house, it's a factory. The mission's success hinges on in situ resource utilization, ISRU, essentially living off the land. The shadow harvest. NASA is deploying specialized rovers like Viper 2.0 into craters that are colder than Pluto. These areas contain billions of tons of water ice. The process: thermal extraction. Massive mirrors on the crater rims reflect sunlight down into the dark, vaporizing the ice. Capturing the vapor, tent-like structures capture the steam, which is then refrozen and purified. Electrolysis. Using the base's massive power grid, the water, H2O, is split into hydrogen, rocket fuel, and oxygen, breathing air. The result: The moon becomes a gas station in the sky. With fuel produced on-site, the cost of going to Mars drops by nearly 90% because we no longer have to haul heavy fuel out of Earth's gravity. The safety zone strategy, modern-day homesteading, here is where the politics get intense. Under the Artemis Accords, NASA is introducing a concept called safety zones, the 500-meter rule, to prevent harmful interference from other nations, specifically China's upcoming missions. NASA can declare a zone around its $20 billion base. If you're building a nuclear reactor or a sensitive mining rig, you don't want a competitor's lander kicking up abrasive moon dust nearby. The loophole. While the 1967 Outer Space Treaty says no one can own the moon, these safety zones allow the U.S. to effectively control the best real estate. The Shackleton Standoff. By placing the base on the rim of the Shackleton crater, NASA creates a massive safety zone over the most water-rich area on the South Pole. It's a legal keep out sign backed by $20 billion in hardware. The new space race reality China has already voiced concerns, calling these zones enclosure movements reminiscent of colonial history. But for NASA and Jared Isaacman, it's a matter of protection. If the U.S. doesn't set the rules of the road by being there first, someone else will. Astral Adventure. Here is the final verdict segment. The high-stakes closing that ties the $20 billion gamble to the future of humanity. The final verdict. Brilliant leap or desperate gamble. So, is NASA's $20 billion U-turn a stroke of genius or a sign of panic? The case for brilliance. By abandoning the Gateway orbit, NASA has finally stopped playing it safe. For decades, we've stayed in low Earth orbit or hovered nearby. Building a permanent base on the surface is a hard pivot that forces the technology to catch up. It secures the water ice, it claims the strategic high ground of the South Pole, and it tells the world, and China, that the U.S. isn't just visiting the moon, we're moving in. This isn't a project, it's an anchor for the future Mars missions. The case for gamble. The risks are astronomical. We are taking hardware designed for the vacuum of space and putting it in the abrasive electrostatic death dust of the lunar surface. If a $20 billion base fails on landing or gets sandblasted into oblivion by moonquakes, the Artemis program could be set back by decades. We are putting all our eggs in one lunar basket. The Astral Adventure conclusion. NASA Administrator Jared Isaacman is betting the farm on the dirt, not the orbit. He's betting that infrastructure on the ground is worth more than a station in the sky. As we watch the first modules of the Ignition initiative prepare for launch in 2028, one thing is certain. The moon is no longer a destination. It's a construction site. And the prize for finishing first isn't just a trophy, it's the keys to the solar system. In a major policy shift on March 24, 2026, NASA Administrator Jared Isaacman announced the Ignition Initiative, a sweeping plan to pause the orbiting Lunar Gateway station and prioritize a $20 billion permanent surface base. This pivot aims to establish a continuous human foothold near the lunar South Pole within the next 7 years. The $20 billion three-phase roadmap NASA envisions building this base through dozens of modular missions, shifting from one-off visits to a permanent settlement. Phase 1, build, test, learn. NASA and commercial partners will conduct frequent robotic and crewed missions to test mobility, power systems, and communications. Phase 2, early infrastructure, construction of semi-habitable areas for astronauts, incorporating pressurized rovers from partners like JAXA. Phase 3, permanent presence, transition to long-duration human operations with permanent habitats, nuclear power systems, and a lunar GPS network. Strategic rationale and repurposing space race with China. Isaacman emphasized the urgency of beating China's 2030 lunar plans, stating America will never again give up the moon. Hardware shift. Components already built for Gateway, including the Halo habitation module, will be repurposed for surface operations. Nuclear leap. A new nuclear-powered spacecraft, Space Reactor 1 Freedom, is planned to launch by 2028 to test deep space propulsion for future Mars missions. Impact on Artemis mission timeline. Mission target date. Primary objective Artemis 2, April 2026. First crewed lunar flyby in 50-plus years. Artemis 3rd, 2027. In-orbit docking and system tests. Artemis 4, early 2028. First crewed lunar landing of the new era. Artemis 5, late 2028. Second 2028 landing. Beginning base construction.